Hello everyone, welcome to today's presentation. I'm excited to talk about exponents and powers. This is our first slide, so I just want to start by saying how glad I am you're here. We'll be exploring what exponents are, how powers work, and why they're important in math. We'll cover the basics and look at some examples along the way. Let's get started. Let's take a look at the contents of today's lesson. We'll start with the objective, then move on to an introduction to exponents. After that, we'll explore the exponential rule. Throughout this presentation, our goal is to understand how exponents work and how we can apply these rules to simplify expressions. This is a key concept because exponents are everywhere in math, science, and engineering. By the end, you'll see how these rules help us handle more complex problems efficiently. So, let's dive into the introduction to exponents and build a solid foundation before we get into the rules themselves. Today, I want to focus on our main objective for this presentation. Essentially, our goal is to thoroughly explain the key points in a way that's engaging and easy to follow. I aim to highlight the most important concepts so that they stand out and resonate with you. At the same time, I want to make sure these points connect seamlessly to the overall theme of our presentation, showing how each piece fits into the bigger picture. So, as we go through, keep in mind that everything we discuss is geared toward building a clear understanding of our core message. Today, our objective is to understand how students can simplify expressions by using the laws of exponents. This is a key skill because it helps us work with more complex algebraic expressions more easily. When we talk about simplifying expressions, we're essentially making them shorter and more manageable while keeping their value the same. The laws of exponents give us specific rules to do this efficiently, such as when to add, subtract, or multiply exponents. These laws are the foundation for simplifying expressions like powers of products or quotients. As we go through this, keep in mind that mastering these laws will make tackling algebra problems much more straightforward and help you see the structure behind exponential expressions. So, by the end, you'll be comfortable applying these laws to simplify any exponential expression you encounter. Let's dive into the basics of exponents. Exponents are a way to express repeated multiplication of the same number. For example, 2 to the power of 3 means 2 multiplied by itself 3 times. The key components here are the base, which is the number being multiplied, and the exponent, which tells us how many times to multiply that base by itself. Understanding exponents is crucial because they help us work with very large or very small numbers efficiently. As we move through this presentation, you'll see how mastering exponents connects to many real-world applications, from science to finance. So, keep these core ideas in mind: the base, the exponent, and their relationship through repeated multiplication. Today, we're going to start exploring exponents, which are a powerful way to express repeated multiplication. When we evaluate expressions with exponents, we're essentially figuring out how many times a number is multiplied by itself. For example, 3 to the power of 4 means 3 multiplied by itself 4 times. The key points here are understanding what the base and the exponent represent and knowing how to evaluate these expressions accurately. As we go through the presentation, keep in mind that mastering exponents will help you solve more complex problems and understand a wide range of mathematical concepts. So, let's dive into how to evaluate these expressions step by step. Let's take a moment to explore the history behind the word exponent. The term was first introduced by the mathematician Michael Stifel, who lived from 1487 to 1567. He used it in his work called Arithmetica Integra, published back in 1544. This was a significant development because it helped formalize the way we talk about powers and repeated multiplication. Understanding this historical context really highlights how the language of mathematics has evolved over time and how important terminology like exponent has become in our mathematical vocabulary. It's fascinating to see how a single term can shape the way we think about and work with mathematical concepts today. Let's review how to find the product in different situations. First, look at the example with 5 multiplied by itself 4 times. 5 times 5 times 5 times 5, which equals 625. This shows repeated multiplication of the same number. Next, we have -7 multiplied by itself 3 times, giving us negative 343. Now, a key concept here is the term power. When a number is written in exponential form, the exponent tells us how many times to use the base as a factor. For example, 3 multiplied by itself 3 times is written as 3 cubed, which equals 27. Similarly, 9 multiplied by itself twice gives us 81. Understanding these examples helps us see how repeated multiplication relates to powers and exponents, which is fundamental as we explore more complex mathematical concepts. Let's take a closer look at this table to understand how to read and write exponential expressions. On the left, we have the base, and on the right, the exponent. The goal is to understand how many times a number or variable appears as a factor. For example, when we see 4 multiplied by itself 4 times, written as 4, we can write that as 4 to the 4th power, or 4. This tells us that 4 is a factor 4 times. Similarly, in the example d, we see that d appears 5 times. So we write that as d5, meaning d multiplied by itself 5 times. Now let's look at negative numbers. When we have 6, it's important to keep the negative sign inside the parentheses. If we write it as 6, the negative sign outside could lead to confusion or incorrect answers. Remember, 3 indicates 3 factors of 6, and the negative sign is included inside the parentheses. Also, notice that an odd number of negative factors, like 3 in this case, will result in a negative product. An even number of negatives would give a positive result, so keep the parentheses in mind. Finally, the last example is 5, which we can write as 5. Since 5 appears twice as a factor, we write it as 5 to the power of 2. To summarize, whenever you see repeated multiplication of the same number or variable, think about how many times it appears and write that as an exponent. This makes expressions more concise and easier to work with. Let's take a closer look at the exponential rule. This rule is fundamental when working with exponential functions, especially in calculus. It helps us differentiate functions where the variable is in the exponent, which can seem tricky at first. The key idea here is that when you have a function like a x, where a is a constant, the derivative isn't just a simple multiple. Instead, it involves the original function multiplied by a natural logarithm of the base. This is what makes the exponential rule unique and powerful. Remember, this rule ties into our overall theme of mastering differentiation techniques, allowing us to handle a wider variety of functions with confidence. So, understanding the exponential rule is essential for progressing in calculus and solving real-world problems involving exponential growth or decay. All right, let's take a closer look at this table. On the left, we have the expression PR times PS. Now, when we multiply powers of the same base, which is p in this case, the key rule is to keep the base the same. So the base stays as p, and what do we do with the exponents? That's right, we add them together. So r plus s. In the middle column, you see the algebraic form, PR plus s. This shows the result of multiplying the powers, simply combining the exponents. And in words, we say, to multiply powers of a power, keep the base and add the exponents. Now, here's an important note to remember. When you're multiplying powers with the same base, you do not multiply the exponents. Instead, you add them. That's a common mistake, so keep that in mind. Overall, this rule helps us simplify expressions quickly and makes working with exponents much more manageable. It's a fundamental concept that will come up again and again as we explore more algebraic operations. Let's explore the multiplying power of a power. When we write a base raised to an exponent, like x to the 5th power, we're multiplying by itself 5 times. So, for example, x multiplied by x 4 more times equals x5. Now take the number 3. When we write 5, it means 3 multiplied by itself 5 times. 3 times 3 times 3 times 3 times 3, which equals 243. Remember, it's important to use parentheses when raising negative numbers to a power. For instance, negative 3 raised to the 5th power, written as 5, means multiplying 3 by itself 5 times, which results in 243. Next, look at 4. That's 7 multiplied by itself 4 times, giving us 7 times 7 times 7 times 7, which equals 2401. Similarly, for negative bases like 9, 3, we multiply 9 by itself 3 times, resulting in 9 times 9 times 9, which equals 729. The key point here is that when you raise a number to a power, you're multiplying that number by itself repeatedly, and the exponent tells you how many times to multiply. Also, always remember to include parentheses around negative numbers when raising them to a power, because it affects whether the result is positive or negative. This concept ties into the overall theme of understanding exponents and how powers work, especially in more complex expressions. Let's walk through simplifying these expressions step by step. First, we look at the expression 2 to the 5th power minus 3 squared plus 6 times 4. The key here is to evaluate the exponents first, because according to the order of operations, exponents come before multiplication and addition or subtraction. So 2 to the 5th power is 32, and 3 squared is 9. That gives us 32 minus 9 plus 6 times 4. Next, we perform the multiplication from left to right, so 6 times 4 equals 24. Now, our expression is 32 minus 9 plus 24. Then, we subtract 9 from 32, which gives us 23. Finally, we add 23 plus 24 to get 47. Now, let's look at the second expression, 3 squared minus 8 squared plus 2 times 3. Again, we start with the exponents. 3 squared is 9, and 8 squared is 64. So the expression becomes 9 minus 64 plus 2 times 3. Next, we handle the multiplication. 2 times 3 equals 6. Our expression is now 9 minus 64 plus 6. When subtracting inside parentheses, it's important to do the subtraction first, which gives us 55 plus 6. Finally, we add 55 and 6, resulting in 49. The key points here are to always evaluate exponents first, then handle multiplication, and finally perform addition or subtraction from left to right. This systematic approach ensures we simplify expressions correctly and efficiently. Remember, understanding the order of operations is fundamental to simplifying any algebraic expression accurately.